Okay, so now we're going to look at Boolean type data. So Boolean type data is logically true or logically true or logically false. And how Booleans are defined in Python is using the word true and false. So if we do x is equal to true, so this is title case, and we'll just y is equal to false. These are going to be interpreted as logically true or logically false. Now, if you put this in quotes, then it's not going to be interpreted as Boolean true false. It's going to be interpreted as a string. True false is just a string, a series of characters. So let's just do real quick. We'll do a print type of x just to highlight this. So here we can see that this is type string. And now if I get rid of the quotes here, then it's type Boolean. So it's true without quotes or false without quotes to get the Boolean. Note that it is case sensitive, so if you do true like this, it'll give you an error. It says name true is not defined, and that's because it thinks this is a variable because it only sees title case true as representing Boolean true as opposed to all uppercase. Same is true if you do all lowercase true. That's not going to get interpreted correctly. So it has to be title case, true and false. Okay, so let's talk another. So in terms of conversion, I think this is kind of interesting. I'm going to get rid of this, and I'm going to change this to, we're going to do bool of x. So whatever we put into x, we're going to convert it to a Boolean. So if I put in here true is a string, and then convert that into a Boolean here, and then print, I'm going to change this to y, then we get back a Boolean. So the Boolean function will convert something else to a string. So the string true converted to Boolean true. Again, we could also do false, and that gets converted to a Boolean. Let me just print y also so we can see what it's doing. So true. Which is not what you'd think, right? Which is weird. So let me put in here an empty string and see what it does. So that does false. So it's not actually interpreting it the way that you think it would. So basically, in the case of strings, what it's doing is, if it is a string, it has some values in it, then it's going to return true, Boolean true. If it's an empty string, then it's going to return Boolean false. Let's see if we have a space. If even a space will give true. So an empty string with even spaces count as content, I guess. So that would be false. So what about numbers? So here let's do 0. So if we take 0, convert that into a Boolean, that results in false. If we do 1 and convert that into a Boolean, it converts to true. And if we do any other number, let's do a 174, then that'll convert to true. So basically converting a number to true, 0 will yield false, any other number is going to yield true. Empty string is false, any other string is true. Yeah, that's basically the use cases there. Okay, so another common use of Booleans is within is as output from some logical statement. So here we are just showing some example tests. So I have x is equal to 3, y is equal to 7, z is equal to 2. And then I have some logical tests here. So x is equal to 7, x is greater than y, x is less than y. Let's, for now, I'm just going to comment these out. Let's just look at the results of this. So the first one yields false. So x is 3, 3 is equal to 7, that's not logically true, so it returns false. X is greater than y, so x is 3, y is 7, 3 is greater than 7, that's false, so it returns false, and then 3 is less than 7, that's true, right? So that's one common situation where you see logicals is as the result of some type of test. You can also have multiple criteria, so now instead of, let me just comment out these, and we'll add back in these other ones. So here we have two criteria. So x is less than y and x is greater than z. So and means that both of these criteria must be true in order for true to be returned. Same thing here, I just changed it. And then or basically means one or the other or both of the criteria must be true. So let's get the results and see if those make sense. So x is less than y. So x is 3, y is 7, so that's true. And then x is greater than z, so 3 is greater than 2, so that's true. So they're both true, which is required, so we get back true. If I would swap this out for a less than, then only one of those two things are true, and I get back false, which is the second one, so actually I didn't need to do that. So only one of the two criteria was true, so the and wasn't honored, so you get false back. And then lastly, just one of the two have to be honored, and at least one of these is correct, then it spits it back as true. So you'll see a lot of examples of using Booleans and doing like these logical statements. For example, using for flow control, which we'll see. So that's really common.